All right, good morning, everyone. It's 9 o'clock. I think we'll go ahead and get started to respect everyone's time. My name's Megan Dwyer. I work for the Illinois Corn Growers and would like to
Megan Dwyer's on here.
welcome everyone here this morning. Several months ago, when your Corn Growers Board of Directors decided to host this webinar, we had no idea the events that would unfold. Nonetheless, we're glad you could all join us today as we head into the spring and into what we hope is a seamless.
What you have to do is go to meeting, and
I believe I've got, oh, maybe we're good now. Trying to keep everyone muted. Sorry, guys, for the background noise. Please use the chat feature up in the right-hand corner. It kind of looks like a little bubble. You can click that if you have any questions throughout the webinar. We'll be checking there. Again, we're going to try and keep everyone muted. This session will be recorded, so you can come back and view it later or share it with others. It's now my pleasure to turn things over to Eric Snodgrass. Eric is the Principal Atmospheric Scientist for Nutrient Ag Solutions. He lives in Iowa with his wife and 2 children. So between the 2 of us with small children home today, we're hoping to not have any national newsworthy bloopers.
All right, am I unmuted now? Can you hear me now?
You're good, Eric.
Okay, good. I hope we don't have any national newsworthy bloopers today. And one quick thing, I'm from Illinois, so so I'm an Illini fan here, not a Hawkeye fan or a Cyclone fan. So we'll get into that in a minute. But anyway, I appreciate the opportunity to come in and host this webinar today and speak to you about weather and its impacts on production ag, specifically in the state of Illinois. And you know, Megan was right. You know, a lot has changed in the last couple of weeks, and it's been the news cycle has been relentless, and it's been tough to keep up with everything that's going on, and it's been quite stressful, and makes me and makes others quite anxious at times. And so I thought what we do just to kind of smooth the water out a little bit and have some fun this morning is, before I dig into a spring forecast, can we just do something I think is going to be a lot more fun than talking about that kind of weather? I want to talk about this kind of weather, all right? So back in 1996, the movie Twister was released, and I imagine that almost everybody listening has seen this movie. If you've not seen it, I highly recommend it. It'll be on either CMT or TNT or TBS or one of those stations at least 4 or 5 times per week for the next couple of months, because we're getting into the time of year where we have a lot of severe weather. The movie Twister came out in 1996. Something kind of fun to know about it was the very first movie ever released on DVD. All right, now, when I was at the University of Illinois, I was a professor there for 13 years teaching in atmospheric sciences. I would dedicate an entire class to, in one of my 100 level classes on severe weather, I dedicated an entire class period to all of the bad science in the movie Twister. Now, I'm going to be honest with you. When it comes to all weather movies, movies that have a major weather theme in them, Twister is by far the best, by far the most scientifically accurate, yet it is so bad when it comes to science. So that just tells you it's the best of the worst. So what I thought we would do is we would kind of go through, I picked 4 of my favorite scenes to walk you through today, and I think we could have a little bit of fun at the start of this meeting doing that. So first things first, when you go and you see the movie, right at the very beginning, you meet a couple of the main characters, Bill and Joe, and they'd had some research that they put together where they were trying to put this thing they called Dorothy into a tornado, and from the inside of Dorothy, a bunch of little instruments would be released into the tornado, and it would collect a bunch of data. A couple of neat things about this. One, they said that at that time in 1996, the current average national warning time was 3 minutes. That is accurate. That's how, how short it was back in the early 90s. We, without doing something like putting Dorothy in the middle of a tornado, we were able to lengthen that time to be approximately 25 minutes present day. And something interesting to know, some new research has shown that we do not want to increase tornado warning times any longer than they currently are. And the main reason is they surveyed a bunch of Americans, and they found that if they had an average tornado warning length time of 45 minutes, that the average US citizen would fill that time thinking that the tornado wouldn't get there for 45 more minutes. So we don't want them. We need it to be immediate. We don't want them to be any longer than they currently are. Okay, anyway, what I love about this picture you've been looking at is right here. that is a block eye, like the one for the University of Illinois, and it was put into the movie as a tribute to some of the research done by Lou Wicker and his team back in the early 1980s, where they made something not called Dorothy, but called TOTO, T-O-T-O, Totable Tornado Observation. So that's what they did. They put a big giant oil drum like this in the way of a tornado, not to send up little Pepsi can lid things into the storm, but instead to measure wind speed, pressure, and all sorts of other stuff like that. We abandoned the idea in 1983, though, because it's not a good way to study tornadoes. So with that as your background, I would like to walk you through a few of my favorite scenes. And the first one we're going to walk through, I call Dirt Roads and Cows. So we're going to talk about the dirt roads you see right in through here, and we're going to talk about the cows in this scene. I hope you can all hear it because it's one of my favorite scenes from the whole movie. Are you ready? Here we go.
Never seen flooded like this.
I don't think anybody has.
Bill, we're in the court.
Okay, we need to pause it right there. She just said, Bill, we're in the core. No, you're not. You're not in the core. The core of a thunderstorm refers to the hail core, which means if you were truly in the hail core right now, you'd be getting that red truck pounded by hail. Let's keep going, though. By the way, some of the noises that they use in the movie for the tornadoes are actually pig squeals and camel grunts and gargle noises. Let's keep going.
Flanking line. You can't attack the thing from the south. We're going to get rolled.
Okay, everybody still sees the dirt road, right? All right, here we go. Ready? Oops. Here we go. Watch this again with me. Here we are.
Flanking line. You can't attack the thing from the south. We're going to get rolled.
All right, here we are.
No, you're upset. You just press freeze. I'm not afraid.
Okay, that's a pretty famous scene in the movie, right? There's a bit of a physics problem here. If the winds were strong enough to throw that cow so slowly through the air, they would have been strong enough to roll that truck. And by the way, if you've seen the movie Jumanji, this is not the first time you've seen this cow. That cow was also in that movie, but it was disguised as a zebra, but it's the same computer code that make it. Now, you still see here dirt road, right? Ready for this next scene? Wait a second. I now see a paved road over their shoulders, and watch this, ready? Who's that guy? So you can clearly see that when they recorded this particular part of the movie, they were not anywhere on a dirt road. In fact, they were on interstate being pulled on a trailer, and they got passed by what looks like a red Chevy Blazer in the background. All right, that's scene number one. Let's go to the next scene here. This is a pretty good one. Let's just get it plain and we'll talk it through. So here they are getting chased by a massive tornado early in the morning.
Two questions.
Apparently the sun shines back out. Okay, I'm going to pause it right there. You see this part of the combine right here? Okay, I want you to watch what happens in the next few moments when this hits the truck. Ready? Here we go. Okay, everybody heard it and saw it smash the windshield. Now, this is one of the reasons why I bought a Dodge. I'm hoping that this will work out for me this way, because in a few moments, we're going to go to another scene. Now, you clearly saw it destroy the windshield right here, right? Watch how awesome this truck is. Here we go. Wait a second. How is it already that window has repaired itself? Do you see it here? So this is a magic self-healing truck. How about scene number 3? You ready for this next one? I think it's probably my favorite in the whole movie. In this particular scene, it's the one where they're going to drive through the house. Do you remember that part? Here we go. Okay, I already have problems with this scene. You saw the house roll out from behind the trees, right? Clearly, a very powerful wind must be pushing this house torn off of its foundation across the road. Yet, if I just step you back here and you watch it again, you will notice that the animators forgot to make the trees blow in the wind. Are you ready? Watch it again. So the wind is strong enough to roll the house, but not yet strong enough to blow the trees. Now, I believe that M.C. Escher, famous artist, okay, M.C. Escher must have designed this house, because you ready? Watch how they drive through it. Okay, they went up the stairs, through a bedroom, now through a bathroom. Are you ready? Let's see where they come out of the house. How did they come out of the house on the first floor? I don't quite understand this. And then remember, at the very end of the scene, a teddy bear hits the windshield. It was somebody's job to throw this teddy bear. Are you ready? All right. Now I'm going to mute the last scene for us here, and we're just going to watch it together. This is the very end of the movie, of course, where they've been chased by tornadoes all day long, and here they are getting chased by a massive one that's coming at them. So, of course, they go inside of this pump house, it looks like here, lock the door, and what they need to do next is Bill gets this great idea that the only way they're going to survive is if they can just tie themselves to the piping that is there in the floor of this little building here. So they get these belts and they wrap them around themselves, and here we go. Now the winds, if this is truly an F5 tornado, because remember this was 1996, we did not have the new enhanced Vegeta scale. If this was an F5, this would be producing wind speeds in excess of 260 miles an hour. And remember, it has been going on now for about an hour, which means it will be full of debris, including all of the farm implements here. But all of a sudden, it rips the roof off of this small building, and they're going to hang on for dear life. And you watch this. Now, it's just tearing the barn siding off here. And in reality, they would have already been dead. I hate to say it, but they would have been ripped to shreds by all the debris inside this tornado. But it's a movie. So what do? We get this incredible view inside the tornado where somehow they're able to keep their eyes open. They're not fully covered in mud, and they're now getting sucked up inside of the tornado itself. And I love this scene because big, wide tornadoes like this don't have updrafts in the middle. They have downdrafts. They get smashed into the ground here. But instead, they look up and they actually see blue sky. This is not a hurricane. This is not the eye of a hurricane. It's a tornado. They got this completely wrong. Well, anyways, they're still getting spun around here, and they look up, and this fulfills Joe's lifelong passion of studying tornadoes to see in the inside of an F5, the one that unfortunately killed her father at the beginning of the movie, spoiler alert. And what I really want to remind all of you before we transition into a real weather forecast is that if you think the next time you go out and watch the movie Twister, that you're watching a movie that's all about what real storm chasing is like, you are not. What you're actually watching is how a series of severe thunderstorms producing many tornadoes heals a marriage. So my advice to any of you listening today is that if for some reason you find yourself with your significant other having problems, go storm chasing. By the way, the beauty of storm chasing is you can do it while also practicing social distancing, all right? All right, I hope you had fun for the first 10 minutes today. Let's now dig into what's going on here with this weather, all right? This is what the real thing looks like, by the way. This is a massive supercell from Texas a couple of years ago. This pound for pound is the most powerful expression of weather on Earth, and I have been showing this video for the past 5 years every time I get a chance to talk about severe weather or talk to crowds about ag and weather's impacts, because these storms, while small, are mighty. Why I tell you about them is because our technological increases right now are shooting through the roof. And I've been accompanying that video with this one. It is one of a supercell thunderstorm that we simulated inside of a supercomputer. And why I discuss this is because the rapid advancement in weather analysis and weather forecasting is allowing us to see farther and farther into the future with more accuracy. And it's changing the way we view things like this tornado. This was in Dodge City a couple of years ago. One of my favorite videos of a tornadic circulation beneath a supercell. Nice and steady where the camera person could take a good long video of it. You see, these things, which were once thought to just simply be acts of God, unpredictable, very challenging things to understand, well, we're now modeling them with some of the best computing resources on the face of the earth. We've learned that these storms are full of surprising details. For example, some of our simulations and some of our observations have revealed that most tornadoes are composed of dozens, at times, smaller circulations, like the ones that you see here, each one of them called a suction vortice. And because of that, when we look at the radar signatures for tornadoes, which incidentally was discovered in Illinois at the University of Illinois back in April of 1953, that we now understand that storms that produce circulations with hook echoes on the back of them like this, about 30% of the time, storms that look like the one that you see here produce tornadoes. Now, this is from Kentucky about a month ago, and you remember the severe weather outbreak that hit near Nashville. So I want to show you some of the hook echoes. There's one right there on the backside of this one storm, and the pinks and purples you see on the radar are hail. This particular storm, though, as it went through the western suburbs of Nashville, was able to pick up debris and cast it way high in the sky such that the radar scanned it. By the way, here's one other thing to watch for the next time you see the movie Twister. In that movie, there's a special scene where they're out chasing a tornado, and all of a sudden the tornado disappears, and they go looking around for it. And the guy that drives the station wagon gets out of his station wagon and walks right up in front of the camera, and he's looking up into space very stoically, trying to find the tornado, and it gets really quiet, and he says, "The cone of silence." Now, do you want to know what the real cone of silence is? It's this right here. You see, the radar sits inside that circle, and the black area that you see around it is the space directly next to the radar where it cannot detect echoes, hence a cone of silence. It has nothing to do with tornadoes and has everything to do with the fact that radars are not capable of seeing raindrops right next to them. That's all that is. Okay. By the way, something really amazing that did happen out of that tornado that went through Nashville that I learned was that the crane, so this was a midnight tornado, by the way, so you're not going to see it very well until you see a power flash like that. The cranes are actually designed to pivot such that they keep the broadside out of the wind. So this is one way by which we've adapted modern technology to preserve infrastructure like this. It's incredible to see that. Okay. But to finish up, we certainly know that events like this can do a lot of damage and destruction. And so far, 2020 has started off to be the fourth most active severe weather season on record for us. And those records go back to the year 2000 from the Storm Prediction Center. So this is starting off to be a pretty rough go of it. And this is just some of the damage from in and around Nashville. So let's talk about forecasting. When it comes to forecasting, remember that it's an incredible challenge to try to predict something that can behave in a nonlinear and chaotic way. Sometimes we absolutely nail it. We see all of the right pieces and put them together and give you an outstanding forecast. And when that happens, I feel a lot like this kid. Wiffle ball gets hit or thrown to him, he cranks it out of the park, shoots it on its way out, and does a bat flip at the very end. If you want to watch that again, there it is. Home run. Shoot it on its way out, and a bat flip to boot. That's how we feel sometimes when we really nail forecasts. But you can never get cocky in my field, because as soon as you get one forecast right, another one will creep up behind you and throw everything off course. And sometimes the things that really mess up a forecast are not well seen. And just like this one, you got this cat sitting here watching a motorcycle race who just reaches up and swipes the motorcyclist. It looks as though he knocks him off there. Two entirely separate events. But sometimes that's what it feels like when we forecast weather. Things oftentimes go unseen, and we miss them, and they can really impact what we do. So that's why I want to reiterate this right here. A couple of weeks ago, I was in Wichita, Kansas. Wichita is, by the way, that little smudge you see right there. And I was given a talk in Wichita, and there was a forecast for some snow that day. But by most accounts, we weren't expecting too much. Do you see this right in through here, though? That is an extremely narrow swath of 9 to 13 inches of snow that fell that morning. It looked like this from airplane. I mean, that is nearly impossible to predict. Yet, as an atmospheric scientist, this is the kind of feedback I get all the time from it. I knew nothing would happen. It never snows here anymore. You guys are awful at forecasting snow. You know, it's incredibly challenging to do what we do. But I want to make a simple point at how accurate we are. And this is a slide I think some of you on the call have had me show you before. It's the accuracy of our forecast models. The best in the world is the European model. And the European model's accuracy at 3 days out for giving you a backyard forecast is about 97% accurate. But the farther you go in time, like day 5, day 7, or even down here to day 10, accuracy decreases a lot, such that day 10 accuracy for your backyard or your field, maybe only about 50%. My research at Nutrien is to take this curve and elevate it. And I spend every waking minute trying to figure out new ways by which to do that. And I'm going to tell you why. Markets move on day 10 to day 20 weather forecasts when the market is moving based on weather and weather alone. So we're trying to improve not only the day 10, the day 15, day 20, but as far out as we can possibly see. And I'm going to share with you today what some of those long-range forecasts look like. But I want you to be aware of gimmicks, okay? A couple of years ago, there was a pretty famous weather forecasting company, and I won't name any names, but they produced a video here where the title of their video says, are you ready for $7 corn? Now, who's not ready for $7 corn? Just remember, to get $7 corn, we have to have a disaster in Illinois or Iowa or one of the other Corn Belt states that produces like we do. So in their video, they advertise that every day when they do their forecasts, they perform 61 with all these zeros, all these numbers behind it, okay? 61 times 10 to 103rd. That's how many zeros there are behind the 61. And I heard that number and I was like, wow, that's an enormous amount of calculations. Almost too big to be true. So I did a quick calculation myself. One of the fastest computers on the face of the earth right now is IBM's Watson. Now, if you left Watson on every second of every day for an entire year at full power, it only does 6.3 times 10 to the 24th calculations. And then I got thinking about this again. That's a huge number, 61 times 10 to the 103rd. Well, I've studied a lot about science, and one of the science facts that I learned when I was young was that the total number of atoms in the universe is 1 times 10 to the 83rd power. That means this company who was trying to predict 2016 to be a disastrous summer said they did 20 orders of magnitude more calculations every day than there are atoms in the universe. Now, here's what I want to tell you. When it comes to long-range weather forecasting, it is the forefront of atmospheric sciences. It is the most challenging thing that we do. And getting it right is rare and it is quite difficult. But Illinois has had some clues given to us from this past winter that might help us out understanding this upcoming spring and summer. And it starts here. Over the last 180 days, so this is September 29th, going all the way until today, we can see how compared to average, and average is the dashed line, how our temperatures have behaved. We had a brutally cold October. Remember the snow on Halloween? We then moved into a very mild December and a relatively mild rest of winter with only very brief shots at colder air. The colder air has been extremely limited since November. And one of the reasons for that, we have had one of the most steady and stable polar stratospheric vortexes that I've ever seen. It looks like this when it's really nice and stable, like it does outside today. And as a result of that, look at the blue line I'm animating over there on the right. You see, that's what the stratospheric polar vortex did last year. It crashed in the beginning of January, reached a peak in the middle of February, and crashed again at the end of April. Well, this year, look at the yellow here. That's what the polar stratospheric vortex has done. Much more steady, not really having the huge bounces, and it stayed largely above average. And remember, the more you go up the y-axis of this diagram, the stronger the polar vortex has been. So that's why we've not seen much activity in terms of brutally cold, long-lasting cold air after last November. But as a consequence of that, we've allowed quite a bit of tropical moisture to invade into the state of Illinois, and we have spent year to date, so this is January 1st through yesterday, we have spent in the state of Illinois, on average, that time period, with 125 to 225% of normal precipitation. About the only places that have been dry right down here on the Gulf Coast, partly here in the North Central Plains. We're going to talk about that more in a few moments. It's dry in parts of Colorado and New Mexico and dry out west. Outside of that, the rest of the country is quite wet. So we've just had what I call small doses of winter. We have a 125-year record across the United States, and by state, you can see here that Illinois had its 117th out of 125 warmest winters. In terms of being wettest, we were 105th, with Georgia and Alabama having their wettest on record. Now, thinking about that, what has that done to our soil moisture? So we're going to look at two maps. On the left, I have soil moisture anomalies for this year, and on the right, I had them a year ago. Now, you can clearly see that the Missouri River, the Mississippi River, the Ohio River, and their basins are saturated. The ground is saturated. But what's the difference between now and a year ago? Well, look at how much wetter it was from Kansas through Nebraska, Iowa, southern Minnesota, and Wisconsin a year ago compared to now. Also look at the Ohio River Valley compared to a year ago. What's different is we're wetter in the northern plains in the soil than we were a year ago. And California was wet last year and extremely dry this year. And we need to keep this all in mind as we prepare and move forward with this forecast, because this is what our snow water equivalent looked like last year on this date. We had anywhere between 3 and up to 9 inches of excess water sitting in the soil on the headwaters of the Mississippi River. And that's way different than it is this year. And remember, this is through the 23rd. Go back to the beginning of the month of March, and all of this was filled in with snow as well last year, which made big winter storm systems like this one that went through a year ago back on March 12th capable of producing massive flooding events as it introduced 3 to 5 inches of rain, blizzard-like snows on the backside, and severe weather to the south. In the 20 plus years I've been studying weather and forecasting it, this ranks up there as one of the largest low pressure systems I've ever seen. And it was a year ago back on March 12th. And what it did to the Missouri River was break up the ice in it and chuck it up into the fields. And to date, that one storm system totaled $10.6 billion in damage. $10.6 billion. So it's been an enormous event that happened last year. Well, what about this year? This is where we currently have snow. There was some of the light snow we saw yesterday that went through parts of Illinois and Indiana, parts of Iowa and Missouri as well, and over towards the southern part of Michigan. But currently, the amount of snow we have locked up in the headwaters of the Mississippi River is substantially less than a year ago, and that's good news. But for those folks that farm in this area, by the 1st of 2020, by January 1st, 2020, parts of North Dakota had already seen an entire winter and a half's worth of snow, plus they had a hard freeze on their crop back in October before the crop matured and was harvested. So they're having some problems up there. Here's a couple of videos I've shown recently in some of my weather content of what it's like to get a last harvest done here in March. You see, as they bring the tracks over the heavy ground, the saturated ground, the heaviness of the tractor here squeezing the water out. Can you see it there? And over there on the right, it's the same thing, even breaking up some of the ice. But these folks are desperately trying to get this crop out, because if they can't get it out, all of those acres will go to prevent plant as we move into 2020. So just keep all of that in mind. California, just let me tell you something quick about California. California's February, okay, this past February was the driest February on record for the state. Compared to a year ago, they left over 25 trillion gallons of water on the table, which means they didn't get that in 2020. And why we need to think about this is because at the beginning of March, California's water reserves in their reservoirs were looking okay. But what I circled here is the basin average snow water content. And they were sitting somewhere between 40 and 50% of normal. Now, since then, it's been quite snowy in California, and they've increased that amount up to between 50 and 60%. But on the whole, for the state of California, looking at all of their precipitation, they're right now sitting at just 50% of normal for their whole winter. Much of the rest of the Intermountain West is packed up with snow, but California is not. And that's going to be critical for California's water health come later on this year. You can see where the drought is across the United States. It occupies much of the state of California, most of Oregon and Washington, but the drought in the Four Corner states and Texas is what I want everybody in the call to be watching. Now, it's March 19th when this map came out. If we see by the start of June that this drought has expanded here, or this drought is expanded there. So if drought sits here, where I just made this last circle, I'll color it in for you, and it is in June, this is important for Illinois and Iowa, because the jet stream will more than likely want to go around that. And if it runs over the top of that, we end up getting what's called a ridge right here in the midsection of the country, and that is a hotter and drier pattern. Now, right now, I'm not forecasting that. I'm not saying that that's going to happen. But remember, long-range weather forecasting is challenging. We oftentimes can't pick up on these quick changes that happen, well, maybe in May or early June. So watch it very carefully. Nobody on the call is allowed to worry about this for at least another 2 months, though, okay? I'll tell you when to start worrying about it. Getting into a quick short-term forecast, though, we got an active pattern setting up. This is your rainfall through the end of March. And you can see here that we still have a few more events coming across the state of Illinois that are going to soak us. To our south, where there's been major flooding down here in parts of Tennessee and Kentucky, northern Alabama, Georgia, and Mississippi, they're going to even add more rain to this area. There are some places down here in Mississippi, Alabama, Georgia, and Tennessee that have already received in excess of 20 inches of rainfall since the start of the new year. So for perspective, where I'm from right over here in Champaign, Illinois, that would be like us getting half of our year's worth of rainfall in the first 3 months of the new year. So we haven't done that, thankfully, but it is wet over the next 7 days, which is what you can see here. And here's some of the reasons why. The jet stream right now is a northern branch doing this. It's all bunched up. It has a southern branch, which is a lot more smooth in its flow. We got a trough here and a trough there, and one that's moving across the United States later on today, and one that's moving through the Canadian prairies over the next couple days as well. So every time we see all these troughs lined up out in the western part of North America, we're in for an active pattern. So this is how things shape up. Let's just play this forward so you can see the next few weather systems. Okay, so Monday, relatively dry. We're going to wait for Tuesday morning for some rain to move across the southern part of the state of Illinois. Now, on its way, it's going to produce some strong storms overnight tonight in Oklahoma and then again tomorrow in Tennessee, but that'll be out of our way. We're then going to wait until midweek. This is now Thursday afternoon and evening that we might get some widely scattered showers and storms, so maybe even early Thursday morning as well. But the big show for us is really going to be coming on Friday and into Saturday and Sunday. By Friday morning, we're already going to see a warm front stretching across the state. That's going to be bringing in not only warmer air, but the chance for rain Friday morning, Friday afternoon, and Friday evening. And then as the next big low pressure system comes out of the Central Plains on Saturday morning, it pushes across the Saturday morning, Saturday afternoon, and evening. So soggy start to the week, soggy finish to the week and weekend. And then the big question is, after that, do things slow down a little bit? Because certainly some high pressure builds in. Well, let's talk about that. Good news is any snow coming out of this next 3 systems stays north of us. So I'm glad to say that the snow is staying away from the state of Illinois as we move forward. But this is what I really want you to notice. That big storm system coming through on Saturday, the really cold air is still anchored over the Canadian archipelago, over the Arctic. And this trough that comes sweeping through, yeah, it's going to give us the unsettled weather, but there's no deep dive of cold air behind it. What I want you to be watching with me is what happens in the North Atlantic with that ridge and what happens here over the Aleutian Islands with this ridge. Because as I go forward to day 10, those 2 ridges almost stay in place. And what that does is that wraps up the coldest air, if you can see the middle circle I'm drawing here, tucked away over, well, the Arctic again. And that could relax our pattern a little bit, bring it more zonal across the United States, which is why when we look out exclusively into week 2, the GFS and the European model are saying a slowdown in terms of our weather systems for the midsection of the country. So this doesn't mean dry, this doesn't mean no precipitation, but it means a slowdown. And that is good news because last year at this time, you would not have heard me say the word slow down from February all the way through the beginning of June. No weather system slowed down. Now watch what our temperatures are going to do. Yeah, today is kind of a soggy, wet day. No thanks. We're 7 to 10 degrees below average here. But as I play forward in this, watch what our temperature anomalies do for tomorrow on Tuesday. Still a cool day for the state of Illinois. But this is by the time things get into Wednesday. We're now sitting 5, maybe up to 8 degrees above average. This is Thursday, southern half of the state, 5 to 15 degrees above average. Getting into Friday, much of the same. And getting into Saturday now, look at the nice warm-up we're going to be getting toward the end of this week. But remember, with warm-ups at the end of winter and the beginning of spring, it typically means moisture transport and precipitation. So looking out beyond that, what about days 5 through 10, which get us out to April 2nd? Overall, any shot at colder air coming through that place I just circled there will be brief at best. We're going to maintain a warmer bias as all the cold air goes sitting up here underneath the trough that is over Alaska. And let me talk to you about days 12 through 14. We will get a brief shot at some cooler air that does come through, but the flow pattern has to do this to bring us that cooler air. And the good news is a flow pattern like that is also a drier one. So while we might get some cooler air to start off the month of April, just a couple of days of it, it doesn't mean that it's going to stay cold, and it certainly is good for drying things out of not getting more precipitation. Beyond that, what you're now looking at on the left is the GFS, and on the right is the European model. And both of them look as though as we work our way through the first full week of April, the chances of seeing below average temperatures are relatively minimum, which means our better chances of seeing near average start to April is pretty darn good at this point. Now, just for brevity today, I'm not going to walk you through all of the different reasons for this. I'm just going to give you the outcome. I'll show you a great resource if you want to hear me talk through the details if you'd like to learn those. But for right now, let's address a question I was asked last week. I was approached by a farmer in Iowa who said, is there any chance that we could see a repeat of April 2018? Now remember, Iowa has been relatively dry over the last month or so compared to other states in the Corn Belt. And this guy wants to get out on some of the warmer weather that's forecast and get going with crops. And he's afraid of an Arctic plunge. So I put this in a video last week to help explain it to him. Yes, Iowa and Wisconsin in April 2018 had their coldest. Illinois, we had our second coldest. And I said for the jet stream to do that, we got to ridge out the West Coast and drive a deep trough into the Great Lakes states, a deep one. So the question is that going to happen? Are we going to see that? And the answer is, thankfully, no. And here's part of the reason why. Now, this might be one of the most important graphics you're going to see today from me. It is looking back over the last year. That's what's on the x-axis. So this was March of 2019. This is March of 2020. We're looking at something called the global wind anomaly. Now, for March, April, May, and June last year, global winds were very fast. And as a result of that, we had storm system after storm system after storm system. Beginning in July, when we in Illinois went into drought, the global winds calmed down, in fact, went below average, and then tanked in September and early October. This right here was one of the reasons why we blocked up and did not have the precipitation we would have wanted in July, although I still think some of the June planted corn did pretty well with that drought in July. Since October, we've built up our global angular momentum. It peaked back in mid-January, and it peaked again in the beginning of March. Everybody listening to this video needs the forecast to continue to go down like that. If that happens, that decreases the frequency of winter storm systems and spring storm systems that move across the state of Illinois. That's one very good thing I have for you in the forecast right now. This is also a major difference from a year ago. A year ago, we were just now building momentum in the global angular wind anomaly. This year, we built it early. So what does April look like? Well, this was released on Friday. This is April 1st through May 1st from the European model. And what it wants to do is keep the subtropical jet stream quite fast, but allow for the winds to calm down a bit in the jet stream, possibly block up over Alaska, and potentially lend toward near average to at times drier than average weather in April. And if that happens and we experience warmer conditions, this is a complete change over April 18 and over April 2019. Again, we do not have it the exact same situation as we saw a year ago. What's going on with the cold out west? That's all lined up with the mountain peaks, which have a lot of snow on it. That's all that is. Now, is this forecast a slam dunk? Absolutely not. So much can change, which is why we tend to watch weather on a 2-week horizon. But we stretch our models out and have them look at as far as we can, which is what you're seeing here. So what is the official spring forecast from the National Weather Service and NOAA? Now, this is interesting, and I'm going to spend the week analyzing this. I haven't had enough time just yet because this came out over the weekend. We see that they're forecasting dry conditions to stretch from the northwest to Texas, and they're going to try to keep the Ohio Valley wet for spring. Now, that looks a little different from what I just showed you from the European model. But this is not to say that NOAA is not very, very talented and good at what they do. In fact, we have the best National Weather Service from any country in the world. So let's just take a look at where they're getting some of their forecast information. We have 7 models run in the United States. Put together, their forecast for April, May, and June follows what you saw from NOAA. See the drier conditions here with the wetter conditions in through there. I believe that's where they're getting most of their information. Now, to help you understand the accuracy of those models, let's do this. On top, I have the forecast from last March for April, May, and June from those models. They were saying slightly above average precipitation here and extremely wet over Florida. See that? Extremely wet over the southeast. They forecast near average precipitation. Let me get those drawings out there for you in the Ohio River Valley, including Illinois. Now, the model at least knew that it was going to be wet. And NOAA said, hey, let's make it wet here and wet over the southeast, but extend the wet all the way through the Ohio River Valley. Good on NOAA for getting that right. Because if you use the model alone, its accuracy statistics, which are shown down here in the bottom, 40%. That's not, well, you wouldn't make a bet on that, would you? Here's what actually happened. It's down here in the bottom right. It was extremely wet into this area, as you can see. NOAA did a very good job with this forecast last year, and so did some of the models that we use. So this year becomes a bit more tricky because one of the best models in the world, which also forecast a wet spring last spring, right now suggests that for this upcoming year, from Texas straight up into the North Atlantic, that's where we're going to keep our wettest conditions. I'll kind of highlight them here for you. Now, you notice that across the Midwest and the Corn Belt, we don't see wet anomalies everywhere like some of the other models suggest. And what I'm trying to tell you is this year, unlike a year ago, there is not strong model agreement in the fact that this upcoming spring is going to be super wet. Now, before we go any farther, let's talk about temperatures. This was NOAA's forecast last March for April through June 2019. Warm in the northwest, warm in the east, cold in the midsection of the country. This is what happened. Tip my cap to NOAA. They nailed it. Look at this. That was what they forecast. This is what happened. Excellent job picking up on this temperature pattern. This is what they're forecasting for this spring. They're thinking the cold's going to continue to come out of the Canadian prairies and hit parts of the, Montana, North and South Dakota. For the state of Illinois, they keep us on our warm bias, which I 100% agree with at this point. But let's keep going with this idea and looking over at the European model. You see, the European model is a little different solution. It actually has almost the whole of the United States carrying a warm bias, with a bigger warm bias out west than there is across the rest of the country. What I'm trying to tell you is right now, there is very little evidence that we should go over to a cold April, May. I don't think it's going to happen. We could get shots of cold air, it's no doubt. But to say it's going to be cold like 2018, I don't think we're going to see anything like that in the upcoming forecast. What about flooding? A year ago, this was the spring 2019 flooding map. You can see that we knew we were going to have extensive flooding because of all that snowpack I showed you here earlier in the video. So this was a very good forecast. This year, a little bit different, where they've had all that excess rain down in the south and southeast. Yep, made a moderate flooding there, but they don't quite have the severity of the flooding across the Corn Belt states as we did a year ago. And remember, the Red River of the North drains to the north, still can cause flooding in the Dakotas and Minnesota, but it drains to the north while everything else goes into the Mississippi. So our flood threat is back off of what it was a year ago. So I asked this one last question here. The graph you see in the background goes from 1948 to 2019, and it looks only at the state of Illinois, and I wanted to identify what were the wettest April through June time periods on record. And you can see them. There's a bunch recently, and there's one back here in 1957. I grabbed all of them, I put them together, and this is what we've got to have. We got to have the jet stream dive down here toward Hawaii, build into a huge ridge over Alaska, cut back into California like this, and then come racing over a big ridge that sits right here off the East Coast. If I'm going to forecast a super wet April, May, and June, that's the pattern. Now, I know it was a while ago, but what I showed you earlier in this video is we don't have that right now. It's not like that at all. It's different. See, when the forecast pattern looks like this, which is what it looked like last February, March, April, and May, where the jet stream split, dove down into a deep trough, met up with the subtropical branch, and then raced across the United States, that's the type of flow pattern that unleashes Gulf of Mexico moisture and soaked us. What did that do? Well, this is an image every day from April 1st all the way through the end of the growing season last year. 2019 smashed records for the frequency of these low pressure systems and how wet they made the midsection of the United States. To show you some numbers, 2019 currently ranks as the second wettest year on record from January to December. For these regions where it has the number 125 in it, those are the wettest in the last 125 years that we've seen those regions. And by state, Illinois hits 121. Reason why we're not 125 was because of the drought we had in July. 121 out of 125 though. And by region, the hardest hit part of the state of Illinois was the northern part of the state. This is what it did to our major river systems. And if you've seen me present this fall or this winter, I've shown this multiple times. But this is what it did to the Mississippi River. You can see the massive flooding here on the Mississippi that we got from all that snowmelt and excess of rain early. And across the midsection of the country from April 15th to June 30th, we averaged inside of the circle I just drew here an additional foot of rainfall. That was what we had in excess during our planting time period. A couple of interesting pictures from that time. I've been showing these all the way since last fall, but they're some of my favorites here. You got a guy here taking a picture of his corn crop on June 18th, 2018 over here on the left, June 18th, 2019 over here on the right. This guy in Indiana planted his corn 6 weeks later in the picture on the right, and that's the difference it made. And you may have seen me show the picture. It's one of my favorites because that's my son, Graham. I made him jump out of the truck here on July 9th and had him go stand by the corn, and he didn't want to, but I made him do it. He's like, Dad, why do we have to take that picture? I said, Graham, you're 4 feet tall. It's July 9th in Muhammad, Illinois, and the corn is up to your waist. I've never seen this before, and this is something your dad studies every single day. 20 million acres of prevent plant. Where I might expect to see more this year, down here, where it's been so wet, and also here, where they're going to be dealing with snowmelt and flooding. That's the two areas I'm concerned about for prevent plant in 2020. And when we put it all together, United States, $5.3 billion in flood insurance. Illinois was second at $473 million paid out. When we think about what's going to happen beyond this, what I want to show you here is what the planting pace, for corn looked like in 2019. It is the new benchmark against everything else that we are going to measure in terms of corn planting pace. What was amazing was this was all the market reaction we got out of that, well, incredible time we had in spring 2019. Up here is 2012. And just want to remind you all of something, especially during this time. I often find that farmers, I listen to you, I watch Ag Chat, I watch Ag Talk, I listen to what you talk about, I'm on Twitter. We often fight about things. We don't need to fight like the Reds and the Pirates here. Because when we fight, you know what maybe the USDA does or what the markets do? They're like that cop you see there, looking the other way. They don't care a lot of times what we're arguing about. So I'm going to tell you what I think about this upcoming season, all right? If we plant off pace, which I'm not anticipating, but if we do, I think the markets will remember 2019 and act accordingly. If we are not behind that pace, I think that this upcoming year will not see nearly a sizable spring rally simply because of weather, all right? Now, some other things might force that. But what we need to talk about after this is this map right here. So I've highlighted bullet points 1 through 4 over here on the left-hand side. We now need to talk about bullet point 5 as we near the end of this forecast video. Ready? We have been noticing that over the last several weeks, cooler water has emerged here and cooler water has emerged here. And one of the reasons why is because the trade winds have been quite strong recently. That's piled up a bunch of warm water, I'll put a W in it, over here in the western part of the Pacific. Now, when we start to see the trade winds denoted by that arrow being stronger than normal, well, many of us start to think about the presence or potential existence of La Nina. Now, we have not had a La Nina-like summer in a very long time. But if it does occur, such that the waters stay cool inside of this area that I'm drawing right in through here, that is one of the best early season indicators that we might have a hotter and drier July. All right? Now, right now, are we forecasting that? Well, kind of. There is anticipation that the waters in through here are going to stay slightly cooler than average. That's not full-blown La Nina. Okay? That's not 2012 La Nina. That's not, 1988 La Nina. This is just cooler water. And right now, none of the forecast models are predicting that all this is going to cool off as well. And if they're not forecasting that, then there's nothing in the cards for me to say that this upcoming summer is going to be a scorcher. But what I'm telling you is, unlike the last few years, where we didn't have cool water here, there's one more piece of the puzzle that's coming together that we're going to have to watch carefully to see if this upcoming summer could possibly present some summer heat and drought issues that we're going to have to pay attention to. Now, I'm looking at the clock and it's 9:49, so I'm going to do something really quickly here. I want to fast forward to a couple of other, you know what, let's do this real quick. Forget it. You guys have a few extra moments, right? Here we go. Something about Brazil really quickly. What you're looking at here is Brazil's yield, production, and area curve. So before I give you one last piece of information about this upcoming summer for us, I want you to know what's coming out of Brazil. First of all, the area that they plant every year has been growing at a rate of 600,000 hectares of new land every year. This year, they planted 1 million additional. They've right now backed off on the current total soybean production number, somewhere between 123 and 125 million metric ton. That's still going to be their biggest crop ever, but they've backed up on it because the states of Paraná and Rio Grande do Sul have had some drought recently. Now, the big state is Mato Grosso right here. And Mato Grosso, when I say big, is enormous. I put Wisconsin inside of Mato Grosso, Iowa inside of Paraná, and I put Illinois over Argentina's main growing area. So you can see how big of a growing area Brazil has. And by the way, right now only 8% of Brazil's arable land is currently used for crop production. And no, that does not include the Amazon. Okay, this is just arable land they have outside of the Amazon, which means Brazil's ability to expand continues. They had to rapidly harvest their first crop of soybeans because it went in several weeks late, but they got most of it out on time, and therefore the northern parts of Brazil's growing areas, specifically Mato Grosso, got their first crop out and their second crop in relatively well. But in terms of that safrinha corn crop, 40% of it was planted outside of the ideal planting window, and they've recently lowered some of the numbers down from 100 million metric ton to 98 million metric ton. The problem areas are right here, and over the next 10 days, that area, especially in the next 7 days, is showing up dry. So I want to give you that piece of information about Brazil and Argentina in southern Brazil specifically. Also around the world, you probably heard a lot about the locust problems that we've been having. This was some of the recent video footage of the locust in the Horn of Africa, which is where Somalia is, Kenya, Ethiopia. These swarms of locusts have been just incredible to say the least. And this was the most recent video about a week ago in Saudi Arabia. Now, where these locusts are currently sitting, are they of any threat to any global food supplies? The answer is no. In terms of local food supply, absolutely. Are they going to get to China? I do not think they can. One, the Himalayas are in the way. Two, if they can move across India during the monsoon, I don't know how the monsoon doesn't flood them out completely. But I wanted to keep you aware of what's going on in these areas. Okay, here's my last piece of information for you, all right? When we think about Illinois and we think about the potential for summer being hot and dry, just know that it would have to break a long-term trend in order to do that. What you're looking at here is that since 1981, Illinois has doubled its frequency of 2-inch rainfall events per day. 2-inch rainfall events per day. So what that means is that we're seeing more very heavy rainfall events happening with longer dry spells in between. To further this argument, the whole of the Corn Belt from April to October has added 5.5 inches of rain on average. And what that means is with this increase in total precipitation across the Corn Belt, having big drought years like we had in 2012 or 1998 are much less prevalent as they were back in the 40s, 50s, 60s, and 70s. It does not mean we can't have a dry year. That is not what I'm saying. It just is saying that the longer term trend is away from it. So I've been showing this video for the last 4 months, and it just talks about one of the ways I think we need to be thinking about longer term changes when it comes to weather, and that is we need to be thinking about better water management strategies. And we can talk about that if we'd like, but today, given that it's 9:53, I want to wrap this up with one last story. I know that none of us right now are able to watch basketball, so we know that our sporting events, because of COVID-19 and out of the abundance of caution and care, have been canceled. But this winter, I've been sharing a story. Maybe you've heard it from me before, but I want to share it one last time. It's about this young man right here. You see, this is Ferdinand. In the late 1960s, he was the mainstay of high school basketball. Everybody watched him all over the country because he was 7'2", and he weighed 200 pounds, but he could score at will. Here's a picture of him in high school shooting the ball over some of the teammates and folks on the other team. He was so good at basketball that he took his high school team on a 71-game win streak. So, of course, he was recruited to play college basketball, and the guy who won the recruiting battle was John Wooden of UCLA. Now, being a big Illinois basketball fan, I love Kofi Cockburn, our new center. I'll tell you something, young Ferdinand here was a much, much bigger center and had a much more dominant blocking presence than young Kofi. By the way, just his first name is Ferdinand. The rest of his name is Ferdinand Louis Alcindor Jr. And poor Alcindor Jr. here, when he played college basketball, was so good that the NCAA changed the game on him. That's a quote from the NCAA saying he could dunk and score at will, so they banned the slam dunk from college basketball. Can you imagine watching college basketball without the slam dunk? He still took UCLA on an 88-2 three-season game kind of win streak here. And young Alcindor Jr. went on from the NCAA, where they wouldn't let him dunk and score at will like he could, to figuring out a new way to score at will by developing his iconic hook shot. You see, Alcindor Jr. eventually changed his name to become Kareem Abdul-Jabbar. And his long and prolific career in the NBA currently has him as the scoring leader for the NBA. There is one active player that could come close to catching Louis Alcindor Jr. or Kareem Abdul-Jabbar, and that is LeBron James. LeBron still needs to score 5,000 points to catch Kareem Abdul-Jabbar. And remember this, for a big chunk of Kareem's career, there was no three-point line. He did all of his scoring in the paint, which LeBron, we know, doesn't. Now, why am I telling you this? I'm telling you this because the game has changed. It's changed because of weather, it's changed because of long-term trends and market behavior, and it has changed most recently because of COVID-19. We in agriculture are the most prepared, most ready to adapt to change and mitigate. And what I want you all to be thinking about is how to position yourself for success in 2020, knowing what the economy is going through, knowing what people are going through, knowing how the world is going to react. Because there's one thing people need regardless of how the economy is doing, and that is the very base of our food supply. So please don't forget the vital role that we play. And with the changes we're seeing, think about ways to position yourself to be successful while all of the rest of this chaos is going on. Kareem did it. I think we can do it as well. All right, I want to give you something for free today. I produce all my weather forecasts 5 days a week on this website right up here, my.nutrientagsolutions.com. It is free, no obligation. You can go check it out. I've been forecasting for 20 years. Watch the video on the right here. Been showing this one since January, all right? I have gotten all of the rookie mistakes, like this young man here who's clearly never welded before. I've gotten all the rookie mistakes out of my system. I will not sensationalize the weather. I will tell you when I don't know what's happening. But I promise you that if I don't know what's going on, very few people will. And as a result, you're going to get the most concise and the most up-to-date, and I hope the most accurate weather forecast information I can provide. It is free right there on that website. All right, I went 57 minutes. I hope you enjoyed the twister part at the beginning of this, but I am more than open to questions, Megan, if you've got them ready for me.
Yeah, thanks, Eric. Just a reminder, we've got everyone muted. So if you do have any last minute burning questions up in the right-hand corner in the little chat window, feel free to send them in. We'll keep Eric on the line for just a couple more minutes and see if anything comes in.
So Megan, did you enjoy the twister part?
I did. I thought it was great. I appreciate everything you presented to us today.
I thought it'd be kind of fun to make fun of that movie. Why not, right? It's an oldie but a goodie. So.
Right. And again, a reminder.
By the way, at the beginning of this,
joined in late. We are recording this, so and it will be posted shortly, so you can watch it if you were joined a little late. All right. Well, I think they're going to let you off the hook pretty easy today, Eric.
Hey, good. I don't mind that.
All their questions.
That never happens, right?
All right. Well, thank you.
All righty. Thank you, Megan.